All right, everybody, welcome back. I see there's a question in the chat already, which is awesome. So today's lesson is on multidimensional arrays. This is really a generalization of stuff that we've already done. So we've looked at single dimensional arrays. Java multidimensional arrays are similar, but they extend that idea to allow us to support more than one level of index. And multidimensional arrays are a great fit for a variety of different problems because they're a great fit for a great deal of the data that we find out in the wild. There's some examples in this lesson, a discussion of types of multidimensional data that you might find. And it turns out that a lot of data that you might think is linear turns out to have sort of hidden extra dimensionality to it, right? So for example, you might want to, collect temperature readings or something like that. And you might think, oh, okay, well, that's linear data, right? It's just time series, right? It's one point, and I put it into an array and it's sort of like spaced out over time, right? So it's sort of linear data. But then frequently you're going to collect, maybe more than one measurement from two different devices or from different places. And so now very quickly we add this second dimension to what had started out as one-dimensional data. Sound is the same way, right? So any decent, basically, since the dawn of, recorded music, I think earlier recordings were actually done with only one track, but very quickly people realized that if you put two different tracks, so there's actually two different signals on the audio that you're playing on pretty much any device. One is designed to come out of, to enter into the right ear, the other is designed to enter into the left ear. And by manipulating those two different tracks, you can actually create a sense of space. You can create positioning of different parts of the sound sort of within this like 2 or 3 dimensional space. And essentially it has to do with kind of manipulating the time at which signals arrive, right? So if I have an audio signal that I hear first in my right ear and then in my left ear, my brain thinks that signal comes from over here somewhere. And your headphones can trick you into thinking the same thing, essentially. And there's a whole art and science that goes into audio engineering that I'm not going to get into. But the point is that even stuff that you might think of as being linear very quickly pulls up these other dimensions. And so having the ability to work with this is really useful. Okay, so the cover sheet here kind of throws out the syntax, which today's lesson is really kind of looking to you to identify patterns and extensions to things that you've already seen before. So we've seen ways to initialize a single dimensional array. We had our type over here, so this is an array that's going to store ints. We know it's an array because I see these empty square brackets next to each other. That's what tells me this is an array. And it turns out that syntax can be extended. So this now says I want a 2-dimensional array. So this array is going to have 2 indices. Remember before we talked about arrays with respect to metadata. What metadata does an array associate with each item inside of it? So once I put things into a single dimensional array, I've established an order, meaning that every array now has, this extra piece of metadata, which is the position that each piece of data inside the array not only has the data value, if it's an int array, it's an int, if it's a double array, it's a double, if it's a car array, it's a car, but it has a position, that integer index within the array. A 2-dimensional array expands that further. So now every int within this array has 2 pieces of metadata associated with it. It has the first index, or an index in the first dimension, and the second index, or this index in the second dimension. And later in the lesson, and we can talk about this a little bit in today's walkthrough as well, we talk a little bit about understanding the semantics of what those 2 indices mean, because it's really up to you. There's a lot of different ways to use multidimensional arrays as part of your programs. They're quite flexible. And so, you can set up your own, one way to think about it is every int that you put into a multidimensional array has this pair associated with it, a pair of ints, the first index, the second index. That's the metadata associated with the data in my array. And so, you can decide what those mean, right? They could be position. That's a common use for multidimensional arrays, but they could be lots of other things too, and you get to kind of make up that as you go along. All right, so let's talk about this particular type of syntax and what happens when I do this, right? So this is, remember when we initialized our single dimensional arrays, this created an array, and I could determine that the length that was set up for this array is 8. And so that means that this array has valid indices 0 through 7. So there are 8 items that I can put into the array and 8 pieces of metadata, those indices from 0 to 8 that I can associate with those items. And so I can say, that I'm going to set the first position of values. But another way to think about this is I'm associating the piece of metadata 0 with the value 10. And then I'll associate the piece of metadata 7 with the value 8. And I can set and retrieve these using this index syntax. This is what we were familiar with from single dimensional arrays. This is, hopefully starting to become second nature. One of the things that we pointed out is because array indexes start at 0, the length of an array is not a valid index in that array. It's one too far. So values has length 8. If I try to use 8 as an index in values, I see this error that indicates that I have used an invalid index. And that's because, and again, this is probably a super confusing error message for someone who's not a computer scientist. It says index 8 out of bounds for length 8. You would think, well, you said I had 8 values. This is the 8th value. No, this is the 9th value, or 1 off the end. Two-dimensional arrays with this particular syntax work completely identically in the sense that I can provide both a size for the first index and a size for the second index. And so this now means that every point, or every value, within this array is going to have 2 pieces of metadata. It's going to have a first index that goes from 0 to 7 and a second index that goes from 0 to 7. If you think about the combinatorics there, that means that this array can contain 64 different values because there are 64 different unique combinations or pairs of indices, first and second, right? So 0, 1, 0, 0, 0, 1, 0, 2, 0, 3, that's 8. 1, 0, 1, 1, 1, 2, that's 16. And I keep repeating that until I get to 7, 0, 7, 1, etc., 7, 7, that's 64. And so the size of the array also determines the size of the number of unique pieces of metadata that are associated with values in the array. And so when I print off 8 here, this is actually printing the size of the array in the first dimension. Now, when you initialize an array this way, what Java does for you is it sets the size of every second level array to be the same. And so if I do something like this, let's go through the first part of this array, or the first dimension. And we'll print off, and now what I'm going to do is I'm going to print off the size of the array inside the array, and you'll see that it's always 8, and let's change this to 4, and now you see that it's 4. So what's actually going on here, right? So this is a good example to kind of stop and think things through and try to kind of like look at things carefully and make sure that we understand what's happening. This is another one of those places where you squint at things and you try to pick out the stuff that looks familiar and you try to identify the things that look unfamiliar and you try to kind of make some guesses or hypotheses about how the two are related to each other. So, this type of loop we've seen before when we were working with one-dimensional arrays. This is the same loop I would write to loop over the values in my array if it had a single dimension. Now, here's what's new. So inside this, I have this values I.length. So when I was working with a one-dimensional array, values I would have been an int. And ints don't have a length property. So for example, if I do this, right, now you're going to see, oh, sorry, this has a problem up here, but let's do this. Now it says int cannot be dereferenced. I'm trying to, access this length property of a primitive, of a value of a primitive type. This is an int. I can print values I, and that's just going to print 0 because this array is initialized with zeros. That's the default value for an int type. But what I was doing before is I was actually printing this values I.length as if values I is also an array. And that's because it is. That's because you can think of in each one of the first spots in the array contains another array. And so, essentially what I've done is I'm going through the first dimension of the array, and every item inside that is actually another array. And so if I wanted to go through all of the positions in the array, now values I is just another array, and I can loop through the indices of that array in the exactly same way that I did before. So now what I'm going to do is I'm going to print this, and now let's print off the indices using string concatenation so that I can see what's going on. Okay, and so now what you'll see is this is the size of the first level array. I'll just get rid of that for clarity. Now you'll see, I'm going through the top. This is I, so I starts at 0, and then I'm going through all the values in the subarray. That's at the first position in the first level array. The terminology here gets messy. I'm sorry. I really am. This is like one of those, there's a few times in this class where I really have to think about what I'm saying. This is one of them. When we get to talking about objects too, there's some places where I just know that there are some verbal minefields. So I'm really trying to be very clear about what comes out of my mouth. I'm not always perfect about that, but I am thinking hard about trying to make sure that this is clear, because again, the verbal syntax here is a little bit confusing. Even if the syntax from a computer perspective is I think sort of clear once you get used to it. And you'll see what's happening is, my I goes 0, 0, 0, 0, 0, 1, 1, 1, 1, 2, 2, 2, 2. That's the index. That's the first piece of metadata. And the second piece of metadata starts at 0 and goes up to 3 because the size of my array in the second dimension is 4. And so every value in this array is associated with 2 pieces of metadata. In this case, I'm calling them I and J, but it's the index in the first level of the array and the index in the second level of the array. If we counted the number of times that this loop executed, we'd see that it executed 32 times, because I have 8 choices for the first index, 4 choices for the second index. Those are independent, and so I have 32 pairs of indices that I can use. Now what I have, just to continue to go slow and think about things, now what I have is actually an int. So if I can do this. I'll say values I_j is equal to I plus j. And so now on the right side of this assignment, what do I have? I have an int. J is an int, I is an int, their sum is an int. On the left side of the assignment, I have to have something that can accept an int, right? So I'm assigning into something, and the place that I'm assigning to has to be something that holds an int. And because so int values I, let's try this. So now it's complaining, right? I can't do this because values I can store int arrays, but values ij, so values can store int arrays, right? Values I can store int arrays, values ij can store ints. I could extend this further if I wanted to, and at some point this becomes fairly tedious. So now I'm going to get the same thing because values ij actually stores int arrays. And so now what I would need to do is continue to extend this and say, let's create a new third level index. Okay, plus plus. And now what I could do is I could say, and this is a case where I'm using 3 indices, values I, j, k is equal to I plus j plus k. That works okay. Oh, it's mad at me about something. What did I do wrong here? Let's see here. Oh, sorry, this should be, okay, there we go. Even I sometimes have a hard time seeing these things, particularly when you start to have these really highly nested loops. So, and again, same thing we did before. values ij stores int arrays, values I stores arrays of arrays, and values stores arrays of arrays. And so if I actually want to set an int value, I have to use 3 pieces of metadata here. First level index, a second level index, and a third level index. And we could just stay here for the rest of the lesson, and we could go through L and M, but you see the point, right? You see kind of how this works. Questions? So to the question that was posted very early on, that the problem with that is simply that remember that the length of an array is not a valid index. So if I try to say values 7, 3, 1, that's a valid index. That's kind of the last place I can put something in this array. So this works fine. Print this value. Right? If I try to use 8 here, array index out of bounds exception, because I only have 8 indices at the first level of this array, and those valid indices are 0, 1, 2, 3, 4, 5, 6, and 7. So if I use 7 here and I use 4 here, same problem. At the second level, I have an array of size 4, meaning that my valid indices are 0, 1, 2, and 3. Okay, same thing here. At the third level of this array, I have 2 valid indices, 0 and 1. For a third level of size 2, 2 is not a valid index there. So this is also going to fail. So this is kind of these are the maximum indices at every level that I'm allowed to use. The minimums, of course, I should say of course, the minimums are zeros. And so I can also use zeros here, but 0, 1, 2, 3, 4, sorry, 0, 1, 2, 3, 4 values. 0, 1, 2 values. If I did this up to, up to 8, I'd have 7, I'd have 8 values, starting at 0. And this is sort of an important component of this lesson, I'll let you guys work through my little rant here, is that like I said before, that what the metadata means in an array is completely up to you as the programmer. The best way to think about it is that with the single dimensional array, you have one piece of information that's an int, and they have to be consecutive. That's the other consideration. We'll talk more later in the semester about different types of data structures that are actually more flexible and allow you to store different types of information in different ways. But arrays allow you to associate one, single dimensional array, one integer index with every value in the range starting at 0 up to the length of the array minus 1. So I've got, let's say I have an array of size 16, I've got 0 through 15. Those are the pieces of metadata that I can associate with the data that I put into that array. And there's a lot of really natural ways to do that, right? So for example, I could take my temperature every day and I could record that in an array, and the position in the array could represent the day that I took my temperature based on some starting point, right? Because I have to start at 0 somewhere, so I have to remember, okay, well, September 14th was 0, 1 is December 15th, 2 is December 16th, and on we go, right? I could do that from now until I was tired of taking my temperature every day. That's one used for single-dimensional arrays. With a 2-dimensional array or a 3-dimensional array or a 4-dimensional array, I just have more metadata. I've got more, I have either pairs of indices or triplets. I have a higher dimensional tuple of indices for each value. What those mean is up to you. I think that particularly with 2-dimensional arrays, trying to think about them spatially is a limited mental model. It's just not going to get you very far when you think about this in terms of rows and columns, like it's like a spreadsheet, right? Well, what if I give you 3-dimensional data? How are you going to think about that? Or 4-dimensional data? You can very easily have a 4-dimensional array in a program, or even a higher dimensional array. It depends on the data you're working with and exactly how you want to structure it. So even when you're working with 2-dimensional arrays, I would encourage you to just sort of like zap out the parts of your brain that have absorbed this. And I know, they're like, oh, well, this is what they taught me in high school. That's fine. You learn things in high school that you need to forget later. Some things you need to remember, but some things are I wouldn't say forget, but we're just going to sort of broaden and deepen our appreciation of this topic and come to see that there's a lot more subtlety here. I can do a lot more with the 2-dimensional array than just store rows and columns. I can use those to solve a variety of problems. All right, metadata. Yeah, okay, great question. So, I mean, metadata is data about data. So the data, so, let's use an example, right? Let's think about this photo of my dog. So each pixel in this photo is data. Now, on some level, that's the raw data that was captured, is the measurement of the intensity of different colors of light. The metadata here is the position within the photo, right, of each one of these pixels. So again, if we set this up with the two-dimensional array, the contents of the two-dimensional array would be the actual, which would be a number that to the computer it interprets as a color. And this is really how this works. So I mean, at some point somewhere in the computer, there's some area of memory right now, if you're on this page, that is filled with a grid corresponding to all of the individual pixels of this image, right? That was captured. I don't know, we took this a long time ago, but he was a younger dog back then. But that is the data, right? The metadata is the positional information about every one of those pieces of data. So if you just took all of the data out of the array, the data that's actually stored in the array, right? So if I go and I just go into the computer memory and I take all the data that's stored in the array and I don't take the position, I don't really have enough information to reconstruct the photo. I know about all the individual pixels that make up the photo, but without knowing where they're supposed to go, I don't have a picture. I just sort of have a jumble, right? And so the way I like to think about it when we talk about these types of containers for information, right? Arrays are our example of this. Variables are our example of this. We'll talk more about different types of these later in the semester as we continue to learn about computer science and broaden our appreciation for this kind of thing. But they all have different types of metadata that they associate with the actual data that's contained in the container. Calling it metadata maybe makes it seem like it's not important, but hopefully it's clear that the metadata in many cases is as important as the data itself. The two of them are need to work together hand in hand. But I think again, when people think about arrays, for example, they think a lot about, well, what's the values that I put into the array, and of course the position within the array, that additional piece of metadata that the arrays add to the data they contain, is as important, right? That's why you use an array in the first place to store this type of information, is because you want that metadata, right? I could store all of the raw data necessary to reconstruct this photo in like a string, for example. But if I didn't have a way to reconstruct the position, I wouldn't be able to actually render the photograph. So metadata, I mean, the literal definition of metadata is that it's data about data. And when you represent something in the real world, and maybe this is sort of a subtle distinction, and maybe in some cases it's not that important. You might say, well, everything in the photo is data, right? The position is data, and the pixel values are data, and stuff like that. And that's fine. That's another way to think about it. But I think that it's worth distinguishing between these, because when you start to use data structures, they naturally create this metadata about the data they contain, right? Again, I can't set a value in a multidimensional array or a single dimensional array without also using that additional piece of information, that metadata. And so that is also in some sense stored in the array, even though it's not, the array actually doesn't, the right way to think about this. The array doesn't actually store the position of the data inside of it. The position of the data inside of it is sort of inferred from where it's located relative to the rest of the array. So there, if you put something into an array at position 7, 8, it's not like the array writes down 7, 8 somewhere. It just puts something in a place that to it represents 7, 8, and then when you pull it out, it goes back to the same place. So anyway, I mean, hopefully that's not the world's most confusing answer, but it's, literally, right? It's data about data. And I think that when we talk later in the semester about trees, if you think about graphs, right? Those are examples of other types of really interesting computer science data structures that also bring metadata into the picture. So great question. Let's talk a little bit, this is multidimensional arrays. We're going to give you some practice with them over the next couple days. I don't think that they're going to play a huge role in what we do going forward, particularly this component of them, the sort of non-rectangularity, which we'll talk about for a minute now. But it is something that I want you to have seen and just be aware of. And so, let's look at some different syntax. And like I said, I just want you to be aware of this. You will need to understand the patterns here for working through arrays in order to do some of the homework problems properly. So the idea is that, and this is different for multidimensional arrays than what's for single-dimensional arrays. So with the single-dimensional array, I can never do something like this. So if I try to compile this, you're going to see that there's a problem on line 2. It's expecting me to provide a size for this single-dimensional array. So I have to do that. But what you notice on line 1 is that I actually don't have to specify a size for the second dimension of this 2-dimensional array. And if I extended this out to 3 dimensions, I don't have to specify a size for the third dimension either. I can just use these empty brackets. And so what is going on here? I can't do this like this, okay? This is not going to work. I have to set a size for the first element, for the first dimension of the array. But past that, when I work with multidimensional arrays, I don't. And the reason for this is really because Java arrays are arrays that are set up to store arrays. So when I declare this array like this, and I omit the size in the second dimension, what Java gives me is a 2-dimensional array with size 2 in the first dimension. So the first dimension has valid indexes 0 and 1. And actually, let's play with this a little bit. So we'll say, so I can do 2D 0, but it's set to null. Remember, we talked a little bit about null last week, and null is going to be part of our lives going forward, and arrays in Java can be null. And so what this has done is it's essentially given me an array that has size 2 that is set up to store int arrays at each position, but it hasn't actually given me any int arrays at those positions. If I use 2 indices, now I don't see null, I see this thing that is actually an array reference, and we'll understand why this prints this later in the class. But for now, you just notice the difference. So I provide a size in the second dimension, I get an array, and I can also do stuff like this, right? If I don't provide a size in the second dimension, now I have a null pointer exception because this is null. So the question is, like, why would I use this particular idea, this particular construct? And let's talk about that. So here's one thing that I could do, right? Now, a lot of the times when I'm working with 2-dimensional data or 3-dimensional data, I know what size array I want, and I should just set up the array properly up front. And that's totally fine. But here are some of the interesting things that we can do because of this aspect of how Java works. So let's do this. We're going to loop through the first indices of 2D, or the indices in the first dimension. And now what we're going to do is we're going to say 2D I is equal to new int I plus 1. All right, so what's going on here? This is kind of strange. Well, on the right side of this, I have, this is just assignment. So let's just figure out what's happening on both sides of the assignment operator. On the right side of this, I'm creating a new int array of size I plus 1. First time I go through the loop, I is 0, so this will be an array that can store 1 int. The second time I go through the loop, I is 1, so this will be an array that's going to store 2 ints. And then I'm assigning it into this 2di. And you'll notice I'm only using one index for 2D, even though it's a two-dimensional array. And the reason is, remember before when we were setting values into different positions in the array, 2DI is actually set up to store an array of ints. And so I've got something on the right side that is an array of ints, and I've got something on the left side that stores an array of ints. And so this assignment is totally okay. So let's see what happens if I do that. Okay, that's good. Now what we're going to do is we're going to go through this again, and we'll print off the length of 2D at each level. Oops, sorry. That's the array. And you'll see that this is strange, right? What we've created here is what's known as a non-rectangular array. A rectangular array, easiest to think about this in 2D, but it kind of extends to higher dimensions as well, has, it really is sort of rectangular or square. So every position at the first index has the same size in the second index. If it was three-dimensional, you would say every position in the first index at every position in the second index has the same size in the third index as well. In this array, that's not true, right? Because of how I set this up, the first position in 2D contains an array of ints, which is good, that's what it's supposed to, but the size of that array is 1. The second position in this array also contains an array of ints, but the size of that array is 2. Now again, this is one of those things that's really largely a curiosity, I would argue. There are, I'm sure, some use cases for this type of thing in Java. But I would probably point out that it's much more common to be working with data in Java that is, in fact, rectangular. But you can do this. You can set up things as well. One of the reasons why I bring this up is because I want to make sure that people don't make this mistake. So this is a common programming mistake when people are working with multidimensional arrays. They're setting up their loop, and they do this. And then they say, okay, I'm going to print 2D ij. And this code will appear to run. And in this case, it works. But the problem is that I skipped a value, right? There actually should be 3 values in this array, because the first position holds an array with size 1, well, that's where one of the values is, and then the array at the second position should hold an array of size 2, so there should be 2 more. So why did I skip one? Well, the problem is that I'm using 2d0.length, and so I'm only ever looping j through the valid indices of the first position in 2d, and because 2d is non-rectangular, every level could have a different size. Right now, the only problem that this causes is that we skip a value. And of course, if I was doing something like computing the sum or finding the maximum, this would actually be a pretty big issue. But what about if I do something like this, right? So now what I'm going to say is, now you're going to see I have an array index out of bounds exception, right? And let's make this a little smaller so it makes sense. What did I change here? Well, now what I did is I set up my loop so that it creates a bigger array at the first position. So now let's think about how this works. When I come through my loop, first time through the loop I is 0, 2 minus I is 2. I set the first position of 2D to contain an array of size 2. Second time through the loop I is 1. This 2i minus I is 1. I create an int that can store array that can store 1 int, and I set the second position of 2D to store that array that stores 1 int. And so the problem is when I get down here, 2d0.length is 2. And so that works fine for my first trip through the array, as it always will. But when I get to the second position in the array, the subarray at that position is actually only of size 1. And so eventually, because I'm still using this length from the first position of 2D, the first time through I'm okay, I use j as 0, but then I try j as 1, and this explodes. And I can print off, before I do this, what these variables are. And you'll see that, 0, 0 works fine, 0, 1 works fine, 1, 0 works fine, 1, 1 does not. Because 2D in the second position only has length 1. The way to fix this is very simple. Just always use the length of that subarray. That is the way to do this safely. Now, if you are really, if you want to be really safe, and we won't do this to you. The examples that we use for this class, when we give you 2 or 3 dimensional arrays to work with, the inner arrays will never be null. But inner arrays can be null. And so let's look at how that might work. So let's make this a little bit larger. And let's say if I, so now what I'm going to do is I'm going to put this under an if statement. All right, cool. So now what happened? Well, remember when I set up my original 2-dimensional array, because I left this dimension empty, I didn't provide a size, Java filled in the first level of this with null. And so when I started this loop, 2D0 was null, 2D1 was null, 2D2 was null, 2D3 was null. As I went through here, I replaced those null values with new single-dimensional int arrays, but only for the even indices. So I said if I mod 2 is equal to 0, meaning that I is even, then I change the value at that position, which was null before, to be a new single-dimensional int array, which I can do because each index at the top level can store an array of integers. The problem is now when I come down here into this loop, the first time through I'm fine, you'll see that I see 0, 0, and 0, 1, but the second time I see a null pointer exception on line 8. And that's because 2di is actually null. And so if I wanted to, and this comes, essentially what I would have to do is I would have to say if 2di not equal to null, I'll move this over, checks out, so mad. Now this works fine. And you'll see that, I only, let's see, I'm not sure why I see, let's see here. Why am I seeing, why is, so that should be 0, but 2 should also work. Oh, because it makes it empty. Okay, I gotta increase this. Okay, that's better. All right, sorry, I was confused about why this wasn't entering this if statement when I was 2, because I should have a valid array there. Okay, so anyway, again, I went off on a longer digression about this than I had planned, but this is a feature of Java that you should at least be aware of. Like I said, when we give you problems in this class, we will not provide you with rectangular arrays, but we will not have any of the subarrays be null, so you don't have to worry about this type of thing. One new piece of loop syntax that we're going to see tomorrow, just for fun, that I'll throw in here as a little aside, is actually kind of a nicer way to do this, is to use this statement called continue. And let's see how that works. So essentially, and again, I'll cover this in tomorrow's lesson, what continue does, we talked about break, how break will jump immediately out of the loop and keep going. What continue does is it just jumps back to the top. And so this is a nice way of avoiding a part of the loop that you don't want to execute. So in this case, what happens, I enter the loop. I say if 2di is equal to null, so if there's no valid second level array at this position, continue will cause me to jump back to the top of the loop, increment I again, and try the next value. And so what we can see, I'll put a print statement in here. And now let's just pick these out. So you can see, and let me just make this a little bit more fun. So you can see I skipped 1 and I skipped 3. And when I see this skipping 1, I hit this continue and I don't see the print statement for that value, and that's because the continue took me back to the top of the loop. Continue is not the most common thing to see in a loop. It does get used sometimes, but we will cover tomorrow, and it's useful in certain cases. This just happened to be one of them that I came up with along the way. All right, other questions? I've got just a few more minutes left. Yes, Yeah, these are terrible. So you can use literals with multidimensional arrays. Don't. It's miserable. It's really, one of the things that's terrible about these is they're really hard to read. And so, I dare you to actually try to look at this and tell me what this is going to print, right? Based on this terrible ganky syntax here. And so we don't use these. I'm not sure exactly in what case you'd actually need to use something like this, but it's part of the language. All right, so there's a nice walkthrough here going through, how to extend our programming patterns that we learned for single-dimensional arrays to work with multidimensional arrays. Definitely encourage you to go through that because I think it'll help you on today's homework problem. Today's homework problem is fun. It's a kind of another extension of stuff that we've learned how to do together, and tomorrow we'll have a pretty neat homework problem as well. It's kind of a neat game-based thing. So if there are, I'm going to hang out for just a minute to see if there are any lingering questions. If people want to jump in the chat. Otherwise, I hope that you guys are doing okay. We're making it. Semester is going. Yeah, so we will have a quiz tomorrow. I'm going to put up a practice quiz this afternoon for you guys to get familiar with the format of those. The homework problems or the quiz questions that are programming questions will have an environment that will be equivalent to the homework environment that you guys have been using. So, you're comfortable with that, you'll be ready for the quiz. And I'll put up, like I said, there'll be a practice quiz up this afternoon that'll have questions that are designed to kind of help you prepare for the type of things that we asked on quizzes in this class. So, a bunch of multiple choice questions designed to be quite straightforward. One thing I will warn people about is that, if you have been reading the lessons but not listening to the walkthroughs, you will not do well in the quiz. The lesson text is not designed to be authoritative. We put a lot of work into the videos and the walkthroughs that are part of the lessons. And if you're not following along with those and listening and internalizing what's happening and, pausing and playing around a little bit, and particularly listening and looking at what's being demonstrated, there are things that you're going to miss. And so, there will be parts of the quiz that you'll find frustrating. Okay, looks like we are in good shape. Let's see. Yeah, okay, so I'm going to sign off. It was great to have everybody here today. I hope you guys are okay.